basics exam question number 2. It says, let f be the function given by f of x equals 9x squared minus 36 divided by x squared minus 9. Part A of the question tells us to describe the symmetry of the graph of f. So what I did first was test to see if the function was even. And to do that, we plugged in negative x for x. And then if this is the same as this, then it is even, because f of negative x equals f of x. And since it's even, that means that there's y-axis symmetry. So that's how we describe the symmetry of the graph of x. So part B of the question tells us to write an equation for each vertical and each horizontal asymptote of f. To find the vertical asymptote, we set the denominator equal to 0 and solved. We found that x equals positive and negative 3. So the vertical asymptotes are x equals 3 and then x equals negative 3. To find the horizontal asymptote, we took the limit as x approaches infinity of 9x cubed minus 36 divided by x squared minus 9, and then we got it equals 9 because the powers are the same on the top and the bottom, so you just take the coefficients and it's 9 over 1, so you get 9. So the horizontal asymptote is y equals 9. Part C tells us to find the intervals on which f is increasing. So first we take the derivative of f of x. To do that, we use the quotient rule. So we took bottom times derivative of the top minus top times derivative of the bottom over bottom squared. And when we simplify it, we get this right here. And we set that equal to 0. And whenever we do that, we get x equals negative 3, 0, and positive 3. Now when we put it on this number line, we take a little bit less and a little bit more than negative 3 and see if it's positive or negative. We plug it in the f prime of x, and we did that for 0 and 3 as well. And we found that on either side of negative 3 it was positive, but it's a point where it equals 0, so we still have to include that. So f is increasing on negative infinity to negative 3 and negative 3 to 0. And that is the interval of which f is increasing. Part D says, using the results found in parts A, B, and C, sketch the graph of f on the axis below. So we figured out the asymptotes in part B, and we figured out that the vertical ones are 3 and negative 3, and the horizontal one was at 9. And we also figured out whenever the graph is increasing, which is less than 3 right here, and then from less than negative 3, and then from negative 3 to 0, which is right here. And it's decreasing from 0 to infinity. So this is how we drew our graph: increasing, increasing, decreasing, decreasing, and then staying in these asymptotes.